Repeating a series of steps. A loop is used to repeat a series of steps. There's a couple of different kinds of loops, and the loop we're going to look at today is a for loop. So it's for some variable in range, and here you put just a number for the number of times you want to repeat, colon, and the steps you want to repeat. First warning, any steps you want to repeat are all indented to the same distance inside the for loop. When you stop indenting, and you start writing code that lines up with the for loop, it tells you that your for loop is over. So I tend to let myself know by putting a comment in that this is the end of my for loop. Now, the variable used as a loop counter is often I, J, or K. So why did computer scientists pick I, J, or K? If you imagine the alphabet, mathematicians tend to use A, B, C, D, X, Y, Z. So computer scientists reached in here and said, oh, let's use I, J, and K. Now, again, reminder, the steps inside the loop are all indented. So let's take an example. We're going to print hello 5 times for I, and we picked I again because it's often a loop counter. In range, how many times do you want to repeat? 5 times. And we're going to print hello 5 times. So the computer says, do this, check what I is, repeat, check what I is, repeat, and I just goes up by 1 every time. So it'll say hello 5 times. There's an alternate format. You can decide any starting number you want. You can decide any stopping number you want. Just make sure you add 1 and what you want to go up by. And then again, put the steps you want to repeat, indent it. So we're going to do the same thing, print hello 5 times, but this time tell the computer we're stopping at 1, starting at 1, sorry. And what are we stopping at here? It says take your stopping number and add 1. So if this is 6, that represents 5 plus 1, meaning we're stopping at 5. Going up by 1, print hello 5 times. This is exactly what it did before. Now, what is the purpose of this plus 1? We're going to have to go back to the previous slide to explain. So for I in range 5, the computer likes to start counting at 0. So the computer, there's the first hello. Then it goes to 1, then it goes to 2, then it goes to 3, and then it goes to 4. So to print something 5 times, you have to say, I want to start at 0 and then stop at 4, and the plus 1 is so that the human being understands it's happening 5 times. So again, it's a little confusing because the computer likes to start counting at 0. So if I do something 5 times, I say 0, 1, 2, 3, 4, and there's our 5 times. So this number is always 1 more than what you stop at. Okay, what we're going to do today, for an example, write a program that will find the sum of the squares of the numbers 1 to 15. Again, we always think in our native language first and break it into steps. I'm going to find the sum of the squares of the numbers 1 to 15. I should probably start with the number 1. And then find the sum of the squares. So let's square the number. If I'm finding the sum of things, I should probably add that number to something. Add the square to the total. That's a good idea. So if we've dealt with 1, what number do we need now? We want to go to 2. How do we go from 1 to 2? We're going to add 1 to our number. And then after that, you want to repeat these steps. So I've added 1 to the number. I come back to squaring it, add the square to the total, go on to 3. Square it, add it to total, go on to 4. So this tells you where to put your loop. And when you're done, print your answer. Let's translate this to computer science. Here we go. Start with number equals 1. So number equals 1. This tells us we are at the start of a loop. How does the start of a loop? For I in range. And how many times do we want to do this? 15 times. Square the number. You know how to do that. Square equals number star star 2. Remember that was raising something to an exponent. Add square to total. The right-hand side might be reasonably obvious. Add square to total, that means putting a plus sign between square and total. The big question is, where does the answer go? And this is an interesting line of code. This is a common line of code in computer science. And what it's saying is you have a variable called total. And you have a variable called square. And what number did we say we started with? We're going to start with 1, so I'll show you exactly what's happening. So number equals 1. So number is 1. Square of 1 is 1. And this line of code says, put in total what's already in total plus the square. And what is in total right now? You're really hoping that what is in total is right. What is in total right now is 0, but you should really say that, and we'll add that line of code here in a minute. So it'll say, put in total what's in square plus total. So square plus total, that will then become the number 1. So very common in computer science, when you're increasing a number by something, it appears on both sides of the equation. Keep that in mind on the next one. Add 1 to number. So adding, we're going to add 1 to number, and where does it go? Oh, here we are again. Same idea with this line of code. Number appears on both sides of the equation because that's what's being increased. So very much like this line where total appeared on both sides. Mathematicians find this very upsetting, but as a computer scientist, you're going to get used to it. Okay, so now we're at the bottom of the loop, so that'll go up to the for loop. And when we finish this, we need to print. So the fact that this is indented, and it looks a little strange, but this should all be indented to the same thing. So just pretend that lines up. Because that is indented to the same space as the for, that tells you that you're finished the loop when you get to here. So this will run 15 times and then print the sum. Now, make sure that total starts with 0. You can't rely on 0 being in total. In fact, in a language like Java, it likes to start with -3 billion, and that will throw your calculations off. So anytime you're putting something in a variable, and you're saying, put in that variable what's already there plus something else, make sure you decide what starts there in the beginning. So let's just look at how this works. This is the code. I just added this fancy line so things show up, but it's essentially the code we just wrote. It starts with number 1, it squares it, it adds it to what's in total, so total would have been 0 before, 0 plus 1 is 1. Add 1 to number, square it, add 4 to the number that's in total, that gives us 5. Go from 2 to 3, square it, add 9 to the number that's there already, now we've got a total of 14. Go to your next number, square it, add it to the total. This will continue until you've done this 15 times, and then it'll tell you what the answer is. Okay, what do you need to do? Your job today, you're going to do assignment 3A. 3A says find the sum of the numbers 1 to 100. So you look at the code that I've given you and you change it. We're not going to 15 anymore. What are you going to? Didn't mention squares anywhere, so we're going to take that out and take that out. So your big question is, what are you adding to total? So the rest of the code looks very similar. This would be a different number than 15. This line is completely gone, and this variable is replaced by a different one. When you were adding squares, the variable was called square. When you're adding numbers, what do you think it is? When you get 3A to work, you're going to try 3B. Now, when you do 3B, we're going to be super smart. We're going to take our program 3A, save as 3B. That means you have a copy here and a new copy here. Modify it slightly, and you'll get your program to work. 3C, go back to 3A. Start with that as your code, modify it slightly, and then change it so it works for 3C. 3D, same idea. Start with your code for 3A, modify it slightly, and that'll give you the program for 3D. All right, enjoy yourselves. This is a fun assignment.